So we're live with our first live podcast of the All Things Façades podcast show, live in Boston at the Facades Plus event. And here we have Brian joining us as the first guest. Brian, thank you for coming.
My pleasure.
Actually, I had Daniel on previously in an episode just learning about the BIPV technology. And it's pretty incredible. I think it sounds like you guys are getting a lot of traction in Canada.
In Canada, the US, globally, ultimately, the technology sort of speaks for itself in terms of what it's adding to a specific project. And like any facade application, we're looking to meet the requirements and make an impact.
So do you see a path where this could end up being code-driven?
Potentially, with things like the Boston stretch code right now, every building over 25,000 square feet, 1.5 watts per square foot type thing. Those types of codes are going to be challenging for certain rooftop applications. And we're just going to need more options to hit those numbers. So we've been involved in some pretty kind of backroom design related conversations around that, and have really come up with some pretty innovative solutions, I think, for those types of municipal codes and regulations that are upcoming.
So just for context for everybody, and this was super enlightening for me as well, it's a technology, and I think you can incorporate the performance element of it. So it has this kind of cool, sexy factor to it, but I didn't realize, how architecturally friendly it is it offers in terms of finishes, and really the aesthetic of some of your portfolio projects I've seen kind of looks like it's a architectural grade, aesthetically pleasing metal panel finish or spandrel glass or opaque element that people might want to incorporate into their facade design and then get the additional performance.
100%. And the history of our company is an architectural facade materials manufacturer, solutions provider. So we're always playing in that realm of aestheticism, function, form, and overall envelope performance. The bottlenecks for BIPV traditionally have been upfront, the aestheticism being limited to blue-black panels and only being specific to that type of design. Where we wanted to open that up is ultimately similar to our traditional architectural line. Take the architectural intent, capture that, and integrate the PV, where if you want to showcase it, you can, but ultimately could still look like the same building you've always had, just with a different panel integrated with energy generation, power generation on site.
So I'm sure intentional design, functional design, high performance design should entail different design elements incorporated into different facades based on exposure to sun, exposure to elements, wind, and so forth.
Yes.
Can you see an application where the functional VIPV panels will be on one facade capturing that solar energy, but then you might want to match it on another facade as almost like a louver element where you have like a operational and an operational louver?
Yes. And the answer is everything in between. So we've got projects where we're doing full building, similar to what we kind of showed up on the screen there during today's presentation, but also, applications where, we're looking at the south facade, the remaining of the building is going to have a traditional material like GFRC or another panelization element. And we're aesthetically matching that architectural intent while still maintaining the power generation within our own particular scope. Actually, just our CEO always texts us pictures of finished products. So we just got a really interesting one yesterday on hospital project in Alberta. It's actually it's top of mind right now. So I just want to show you this real quick. We have a little WhatsApp chat. So that's an example.
For everybody watching your video, we'll overlay this photos of this project
For sure.
we're looking at. So our wonderful editing team is going to put beautiful
BIPV there, and then solar facade on the south, and then the remaining, this is the adjacent material there. So just to your point of, whether we're doing the full building or only a specific element, we're matching and integrating into the overall design of a given project.
So this is wonderful. You see a project like this, especially with the shading elements and all the different components and materiality and so forth. My understanding is you're going after certain clientele. You're going after a long-term building owner that is spending money in the right areas, looking for a long-term ROI. And obviously you're not going for the market where they're just going to do a quick flip.
It's almost the reverse. Those clients are not seeking us, but we're providing the right impact for their model. Whereas if you have a buy sell kind of mentality up front, you're not necessarily thinking about the long-term benefit. It's for others. And listen, we have people come to us every day that maybe have been planning this out for a few years, maybe just got wind of solar incentives that they didn't have before and want to know what's the best way to spend this money. So it really sort of depends on, if you're a long-term asset manager, there's a significant impact on lowering your operational costs, looking at your scheduled retrofits and the money that you're spending there, and seeing how you can leverage the solar incentive, but also on-site renewable to just sort of hit all of those targets at the same time.
In an industry that's in certain markets very conservative and sort of risk averse to taking on new products and technologies.
Yeah.
Do you face that battle often? People looking for proven case studies within the market?
Um, Listen, with new technologies, there's always a perceived risk. And the idea is if we're identifying how we can impact a project, that risk is accessible now. And through technical solutions, we can really provide a very high level of confidence, but also form and function on a given project with what we have to offer. So, yes, there is some risk to be mitigated, but where a client has sort of long-term strategy, they have the buildings and they have the intent to decarbonize, to improve their on-site renewable generation, it's always worth assessing. And really what I like to what I like to say is once we can see that there's an impact in an energy model and in a financial case, those numbers basically carry the application through to the full execution.
Because it's such a complicated, this isn't a simple industry and it's a complicated product within. So
Very much so.
as a representative of the company, have you had to master sort of that communication, whether you're speaking to an architect from a aesthetic standpoint, here
100%.
from a performance standpoint, an owner from a risk mitigation standpoint?
Yes, and in fact, we should be able to have that conversation with all parties at the table, and really have it be a collective. So everyone's gonna have their own specific lens on it, but ultimately, we have to be meeting every individual need so that collectively as a group, we can come to a decision and not have conflicting, aestheticism, cost, on-site incentives. We want to be able to talk about that holistically and really stand on the fact that we are going to make an impact or we've assessed this and it's maybe not the right solution. But the point is we're asking all the same questions, addressing really everyone's concerns up front.
So to wrap it up, if people in the architectural community or facade community in general are most excited about the product and want to see some case studies, what's the best city or area to build right now to see some product?
Ooh. Um, we've got a fair amount of work in Canada right now, but this year's really been a pioneering year for our projects in the US that are getting installed, but also some new things we've got kind of in the kitchen. Listen, within Western Canada, Southern Alberta gets just the best sun in the country. That's been a natural place for sort of our initial projects to kind of emerge from. That hospital project I showed you there is in Lethbridge, Alberta. They get 2,000 hours of sun every year. So there's a lot of uh, ground mount and industrial scale PV being implemented there. This is really just piggybacking off of that carbon heavy grid, expensive kilowatt hour, and great sun. So for that reason, that region's really been one of the pioneering kind of areas for us.
So as you hear, and even the most extreme feed dominated climates in Canada, you can still actualize the benefits of this product. So Brian, thanks for coming on.
No worries.
And
Thanks for having us.
yeah, we'll talk more.
Enjoy the rest of the conference.
All right, so we're back for our next segment, and I think everybody's going to recognize this space. We have Jen from Shildan here live, All Things Façades Podcast at the Boston Facades Plus event. So, Jen,
Hi.
first of all, thank you for coming on.
Oh, yeah. Thanks for asking me.
Is there anything, before we'll get into all things Terracotta, is there anything specific in Boston, especially in a energy code-driven market, that you might see more opaque elements incorporated into the facade? Are you seeing an evolution in the shapes and materiality, just the whole sort of landscape on how architects are thinking about planning facade design and elements, maybe away from all highly glazed curtain wall buildings to even curtain walls integrating terracotta, but more lower window to wall ratios?
I think we've seen it for years. And I think that the new energy codes are definitely pushing it. I think that the push toward looking at embodied carbon, looking at global warming potential, and choosing materials that are healthy, green, but also make good neighbors. For us, terracotta, there's a lot of terracotta in Boston. It fits in the city, it fits in the aesthetic and the fabric. But beyond that, it also lasts forever. So we have this thought process of beautiful is sustainable. And the idea that when you build something that doesn't need constant maintenance or remediation or repair, it's going to last forever. So it's this combination of, yes, it's energy efficient. Yes, it has low global warming potential. It's a high performer from an EPD standpoint, but also it makes a nice neighbor.
So I think when it's eliminated these perceptions, when I think of terracotta, I think of complex geometry or shape, of really nice finishes, immediately in your head, you go to higher end.
Yeah.
And maybe that is or is not the case. When you want to introduce terracotta into a project, is it something where architects probably has that in mind, or do you introduce it and it's like the light bulb goes on and it introduces more options in their head?
This is the oldest building material. I think everyone knows of terracotta. And part of the hook is the materiality. Again, that this natural material that works in all of these different types of landscapes. Sometimes the architects call us, sometimes they see it at a facade show of Facades Plus, but the drivers are different on every project. Is it just the efficiency of material and materiality? Yes, we can do these crazy gorgeous shapes and glazes, and you see a lot of that on buildings here and buildings around the country, but we also do public school work in the inner cities. We've done water treatment plants on both coasts, and then we do this very high-end work. So I think that it depends on the budget. It depends on the needs. We can find a way to get this material on all different types of projects.
Where you guys, do you produce out of New Jersey?
We don't. Our corporate headquarters is in Mount Laurel, New Jersey. Our terracotta is produced in Germany, in Bavaria. We partner with the factory that invented extruded terracotta in the 80s. And we, 30 years ago, introduced it to the U.S. Some of the first projects in terracotta rain screen and in panelization in the U.S. are actually in Boston. So we did a lot of early work here. The BRA really liked it. And so we were able to find its way onto, and it fits, it works in these campuses and in the city center here. But
in terms of, it's not a heavy material, right?
It's actually engineered to be as light as it can possibly be. So old style architectural terracotta was very heavy, typically cast in molds. This is today's terracotta. It's extruded through steel dies. There is an I-beam change. So we have these hollows within the extrusions, which allow it to stay light. So our lightest is probably about 8 to 10 pounds per square foot for the material, for the terracotta itself. And then the larger, bigger pieces can go up higher, but not so bad.
Glass.
Yeah, no, and it's sitting typically rain screen in high performing rain screen systems, or it's unitizing curtain wall.
How should people think about size limitations, especially when I don't think you're doing, 30-foot wide panels of terracotta? Is it normally small shapes that are pieced together? And then in terms of optimizing the architecture while also keeping cost in mind, like cost of new dies and shapes, like how much repetition you want to, how there's no one size fits all answer, but how do you want an architect to think about, I want to use terracotta, but I don't have an owner with an unlimited spend.
Right.
So what can they do other than calling Jen?
Yeah. I mean, I think this is a customized material. So reaching out is a great place to start to really keep things under control. But we can make a really big panel. We make 36-inch wide profiles. We can go 5.5 inches deep. We can go 10 foot long. That's not for every project. And that can be much more cost prohibitive on smaller projects, on school projects. But there's a really economical, maybe 12-inch by 48-inch panel that fits, that works in a lot of modules that we also see on a lot of buildings. So it's color, it's repetition, it's how many size changes. There's a lot that goes into it.
Have you had a lot of success integrating terracotta into precast panels?
We've done it a few times. Typically when we've done some projects where there was a blast requirement, for example. For us, so you asked where the terracotta was manufactured, which is in Germany, but our corporate headquarters are in Mount Laurel, New Jersey. We do our own design, we do our own systems, shop drawings, engineering, project management, design assist, sales out of this office. And we have projects all over the country. So we are typically thinking about systems. So open jointed rain screen, high performing systems tends to be the direction that we go. Terracotta and precast is something that we'll see in some markets, not a lot. And also it's a component typically of a blast requirement or something else.
It's interesting because I see a lot of natural stone inlay into precast,
Yeah.
especially in New York, but all the Robert Stern condominium projects, that's what you see often. And I see it as 3 paths: a rain screen where you're clipping on a track system, setting it to a curtain wall supplier or contractor, which I don't think most people think of, that you could do,
Right.
5 by 10 curtain wall modules and integrate that terracotta, have a lower window to wall ratio, call it, and stone, terracotta, any of those materials incorporated into the curtain wall, which is kind of my favorite path that I think people overlook. I think people don't think about the engineered component, engineered side, and they just think of the material and the look.
This idea of art and technology, because we sit at that apex, because it is this beautiful artistic material, but it's highly engineered. And so we're thinking about system performance. We're thinking holistically. How do you produce the terracotta? To your point, what is the best size? What is the most cost effective if that's the need? Or how do we get to this crazy shape with this custom glazing if that's the requirement? But how do we make the shape? What sort of system is the best fit? What should it hang in? What is the performance? is it going to last forever? Is it going to require maintenance? Right. So we don't want caulks, joints. We want everything open. We want everything performing and lasting forever. And then we don't install, but on that back end, we're always thinking, how is this going to be installed? What do we need to do to make this work for the installation partner? And I would say also, you may not think of us and think of unitized curtain wall, but almost half of the projects we're doing these days are in unitized curtain wall. So I think there's a real push toward that in the market.
How do you think about ease of replacement, not even long term, but setting it to a curtain wall guy, he dings a terracotta unit, or even on site, a swing stage hits it. Yeah. Can these units be easily patched, or do you have a certain attic stock in place?
So fortunately, it's a really robust material. It's fired at very high temperatures. We use a very dense clay, so it's strong. To the question of replacement, we have a proprietary clip that sits in every single one of our panels and locks the panel into place. So if one panel needs to be replaced, you can just take that panel out and put another panel in. We're also thinking about replacement in our systems. So as we're designing for the possibility of needing to replace. But it's a very, very simple. We don't typically see a lot of attic stock these days. Some, but not a lot.
So to wrap it up, I'm sure the answer is all over the world, but if you had the opportunity to bring clients, architects, developers to one city or one area and show off, your favorite projects, can't say the Northeast, New York City, Boston, wherever it might look.
Okay.
What's the best area for you to show off?
There's so many. And I think New York, there's so many diverse projects in New York. Some of the first projects in the country were New York, and there are some really wild terracotta projects there now. Boston, the same. We were sitting right around. I could just do a tour and it could last all day. So Boston's another great one. We have almost, 600,000 square feet at the University of Michigan. So I would say, where's the project? And then we can direct you to a very nice amount of terracotta condensed in a location, because we're all over the country. And terracotta, there are these beautiful terracotta pockets all around the U.S. and all around the world, actually.
Well, thanks for enlightening us on terracotta, and looking forward to talking more, Jen.
Thank you. I appreciate it.
All right, so we're back for the next snip with our friends, our global friends, actually, some domestic, some international, from Siderise. And we had Srini before on the podcast. Welcome back. And we welcome Brad on here from the Facades Plus event live in Boston. So first of all, gentlemen, thanks for coming. And Srini, what the heck are you doing over here?
I'm Srini. I'm the Global Partnerships Director at Siderise. I'm here to participate in the facade event, Facades Plus, and support Brad in our journey with the US. We are very new in the US in relation to our products and what we offer. But the global facade market is such a small, where the US market has contractors from the international market or fabricators from the international market, and has so much relevance and interactions.
So Brad here, I don't want to speak for you, but has experience in the unitized world. And do you guys battle in terms of best practices, what you see over the pond versus what you see over here, and bringing Siderise's fire stopping technology here to the States? Primary differences that you see, and how do you think about coming forward with a unified approach on how you want to messaging on how you want to communicate the products to the market?
Yeah, I don't think it's so much of a battle. I think it's just adhering to new practices that can be brought to the U.S. and actually adopting those as, hey, this isn't so much a change, it's a better practice. So you see the same thing?
Yeah, I do agree. Again, there is advancement, there is a shortage of labor, there is shortage of training. So how much you can offer the installer the ease and eliminate the human error as much as possible, because fire protection can be done right only once. And that's when you install it the first time.
Well, we've spoken about this before. Is it's important to have the installer on board and trained properly to understand how they're going to implement on the facade, but isn't more of it around education and awareness within the design community to understand how to specify and integrate these products?
Yeah, I 100% agree, because it starts when the project itself is conceptualized. Specification is very key, because you have to specify. Gone are the days where you specify a product. Now you have to specify a system, because they work together. They have to talk to each other. So if you are going with a very prescriptive approach, then the challenges that we see in the international market is there is no it doesn't comply with the codes and how the products have been tested.
So who is your audience in the sense of, are you trying to communicate to the curtain wall contractors to then relay the message to the GCs and architects, or are you trying to go direct to the design community to have Siderise integrated into the wall? Nonetheless, what is the approach? Because I think a lot of people want the curtain wall contractor or facade contractor to own the fire safing. So in that respect, are you relying on just educating those contractors that they can deploy the right product?
For me, it starts right from the designer, how the specification is written, and then you drop down to a facade consultant who's then taking the architect's intent and developing it into a more detailed document. But it's also important for us to work with system houses, because a facade contractor he may choose to use his own system or go for a proprietary system. So our interaction with them is also very key. But increasingly, what we also see is there are approved and dedicated fire stop contractors who play a very important role in this. A fire stop is not only in relation to facade, but when you take a holistic approach of through penetrations, construction joints, it becomes a very big package, as it is for a main contractor or a GC to award. So even they are an industry targets and stakeholders in a project which is important.
Maybe you guys can talk a little bit about the differences you might see here versus elsewhere in terms of, do a lot of the facade contractors want to take on that scope, or do they want to say it's on a fire stopping contractor to delegate that scope? I know a lot of large scale contractors would say fire safing's not on us, exclude it. And so do you have a lot of that finger pointing, or are you targeting contractors that want to focus on the envelope as a whole?
Yeah, so typically we want to get to the people that make the end decision. And my approach so far has been go to the guys that own that in their contract. So it's the curtain wall contractors. And a lot of the discussion I had early on was roughly 80% of them in terms of my conversation said, if we can take that scope, we will. A lot of times it's contractual. They can't. It goes out to a subcontractor. There's different contract requirements that say, hey, this guy can't cover it. He needs to go out somewhere else. So we go to the people that, like I said, we try to get to the people that are most influential on making the decision, but we have to balance all of the parties that we go to in terms of the main contractor, the curtain wall contractor, and the subcontractor.
Most of these high-rise projects are unitized systems, and the unitized systems are manufactured in a factory and it comes. So the spandrel panels are installed in the factory and the perimeter slab edge is installed in the site. So they should talk to each other also. So it's very important that the specification drives the need, says what the project needs. And it starts with the procurement process also, because if a product is manufactured outside the country, for example, right? Say you have projects for which facades are manufactured in Middle East, India, Asia Pacific. So, and if the project is in the US, then how do you comply with the insulations or the tested systems for this market where local manufacturers are used? You cannot transport the product to another country and bring it back. So how do you source responsibilities is the key. Because there is also a misconception in the industry or myth in the industry that all stone wool are same. So oranges don't taste everywhere the same.
Yeah, well, and do you see a world or a future where code is going to dictate some type of enforcement throughout the project in terms of site monitoring or QA/QC to ensure that that design intent is being implemented on the project site?
Yeah, I think as I mentioned earlier, eliminating the human error. So fires happen in a building because we occupy them. If it's not occupied, they are not going to have any fires. And human interference is very high in the fire stop industry. So eliminating any challenges or mistakes that comes with good training is important. And following through, once we do the installation, it has to be verified whether it's installed as per the manufacturer's intent. And the specific going one step further before was if the specification is as per what manufacturer has tested. So we see codes. So if you take IBC, for example, International Building Code, or if you take ASTM as a standard, they do prescribe how to do an inspection of a fire stop product. How do you do a destructive test to check whether it's installed correctly? The depth is correct. So there are procedures already available. That's why a fire stop contractor is trained to do all that. So that is why when they are on board, the project pace is different and the project completion and the documentation is a bit notch higher. So as a facade contractor, they can do the installation, they can train and they can do it. But the challenges is their primary bread and butter is the facade. You speak to them anything about the facade, they will be able to tell you.
What does the destructive test look like? I've never seen that in practice.
So once the fire stop is installed, so you have to cut it and see whether the insulation is installed in the correct direction, or if it's a conventional system of yeah, exactly, or compressions are in the right, the required compressions are there in the product that's installed, or in conventionally we have used smoke seals on the product, the dry film thickness, wet film thickness, all those. So we are talking perimeter fire stops, right? But again, if you do a through penetration, also it's a similar requirement. And if you're doing a construction joint, top of the wall or wall to wall, so these are required to be done.
Some of the educational videos from Siderise are my favorite, and I've posted a bunch of them that get a lot of awareness and attention because it really kind of easily demonstrates the functionality and the intention. Just to wrap it up from Siderise's standpoint, what's the best resource you guys can share, or where people can find more of that type of content online?
So pointing out to our website, we also have a US website now, but our global website it's a very good resource. For example, in relation to NFPA 285 testings, you will see around 300 plus test references, which is published on the website, where you can see if there is an NFPA 285 test with a particular cladding type and an insulation type and a cavity type. So all those combinations are available. Our website is the best place. But you can reach out to us also. Obviously, LinkedIn has been a great platform of what you have been doing, because you have taken it a notch to a global level where you are bringing in knowledge from outside the country, and also what is being discussed is being very much related outside the country also. So it's vice versa. So I'm very happy to. Our contacts are available on the website, but Brad is the local guy, and what we would also like to offer is there are architects sitting in the US doing a project in Dubai. Okay, so they should know what is the requirement in that particular country. Now there are facade contractors in India doing jobs, facade fabricators in India doing job in the US. So they should know what is the requirement in the US. So with the global footprint, we are able to offer that kind of a knowledge specific to the market and the location of the manufacturing. So that is where we are able to support and take this, or give an opportunity to the facade industry to engage, early engagement.
Awesome. Well, Brad and Srini, thanks for coming on.
Thank you.
And here's your guy in the US if you need him. But thanks for tuning in.
Thank you very much.
All right, we're back with the next snip, and we have Alejandra joining us. So, first of all, welcome.
Thank you.
I'm
Excited.
excited you're here. I think what I really want to talk to you about is, it seems like you've taken, so I don't want to speak for you, but sort of thermal energy modeling expert. From an envelope standpoint, I'll say this is probably relevant to every market, that there's a disconnect between the envelope contractor, the mechanical contractor, and the actual output of the building versus what's designed and what's built. So how do you, because I've had people on from DOE and energy modeling side and the contractor side, and it seems like, you highlight the significance of this and what the implications are in the building, but in some sense it either gets overlooked or people don't care. How do you bring to the forefront the significance of making sure that contractor, design team, energy modeler, everybody's working in sync, that all these little variables that you change have bigger picture implications?
Yeah, that's a great question. And for Massachusetts, the great thing is that the new Stretch Energy Code has certain requirements that need to be highly documented, whereas we didn't have to do that before. The level of documentation for envelope performance and particular details, for instance, is much more stringent than we had. Well, now exists and didn't exist before. And so thought to how we are wrapping this thing up is happening really early in the design. Back in the day, meaning 2 years ago, we'd get to see these and start thinking about it. This time around, we're in SDs and we don't have a building yet. But we are starting to think about, well, how are you going to detail this and what type of wall construction do you think you're going to have? What that means is that with the design team, we're having that conversation much earlier, which means that they are already starting to think, well, what will this mean when we get to construction, and how do we make sure that we're actually following through? There are other things on the performance of the envelope, like infiltration, that on top of being modeled needs to be tested. And so there's really no way around that. And since typically heat leaks through very small places through which air leaks, we are actually teaming up on making sure that if, that air doesn't leak, therefore heat doesn't leak. And so envelopes will be much better because of this exercise. And it's really, I don't think that was, maybe that was the intention of DOER in the state, but really, I think they just wanted to set a particular performance and then just meet it and figure it out. That's how it feels. But what it is leading us to do is to have these conversations early on about detailing and thermal performance, and what are you going to do with your windows, and let's already think about how are we going to test that, because you're going to have to pass, and we need that number. There's envelope, but there's also this thing called TEDI modeling, which is the new energy modeling that needs to be done for most building typologies. That is highly sensitive to infiltration. So we need to know what infiltration you're going to have before you test it. And so for that, we need to think about.
There's two disconnects from what I just take away from what I heard. I sense a lot of people struggle with interpreting the code, which is a huge challenge. And I don't know if the answer is they're delegating that to somebody else, whether that's architect of record. And before I get into the other topic, how do you see that being problematic? It's obviously problematic, but in practice.
Yeah, so I happen to specialize in helping architects interpret the code and owners. And so they typically call us. There wasn't an energy code consultant 2 years ago that didn't exist as a role, and now there is a role. And so I fulfill that role. My company fulfills that role in I'm gonna say all the projects we work on. We were brought in for other things, and then turned out that stretch code was the main conversation, and so we started to do that as well. So that definitely introduces a new role that people should be aware of. I think people should be aware of the fact that, similar to other codes, you don't need to understand every single subsection of the subsection of the subsection, so long you have someone on your team who doesn't, who's keeping track of it. And so there are two things. One of them is that the stretch code is becoming more detailed and intricate for good reasons, because we need to be a bit more specific about how your mechanical system's working, how your envelope in these particular areas is working. Whereas in the past, we would say, just run an energy model and a mechanical's helping the envelope. That's awesome. Now we're saying, no. We actually want envelope to be high performance and mechanical to be high performance, and all of these things to happen. So it's inevitably getting larger. There are more sections, more subsections to read. It is true that the rollout, I think, could have been a little easier. They have done, credit to DOER. There are several technical guidelines that have been issued along with the code that are meant to help people. But I think we're getting into a level of technicality that those are great to kind of just know what code is asking for. But then when you actually need to deliver on a project, you meet someone who knows, like, line by line and section by section, when it applies and when it doesn't.
Well, to what level are these codes being enforced?
Yeah.
And to what level are people designing buildings and buying them out based on certain specification criteria? But like you said, the air leakage testing, blower door testing, and ensuring that you're mitigating your air barriers continuous and you're mitigating thermal bridging.
Yeah.
Then we might be building to a passive house level. It doesn't mean we're certifying the buildings as being passive house. So do you see, like, we fall off a cliff once it gets to the construction stage?
Well, we shouldn't.
I would say we're getting better. We're definitely not designing to passive house standards, like infiltration. You even need to meet 0.35 at 75 pascals. Passive house is 0.06, 0.08, I forget, at 75 pascals. And so definitely it's not passive house infiltration. Many teams are designing so carefully now that when they test, they're like, wait, look at that. We actually have passive house level infiltration.
Why would the code not be more stringent when it comes to air infiltration, but so stringent when it comes to U value targeting?
That is a good question. Paul Armand is around. You can ask him. I would say to be honest, I think the U value targets are unfairly strict. They are achievable. And what we're realizing is that it kind of just takes good design to achieve them. And we don't think for renovations, there was an update recently that allowed renovations to be a little bit more lenient because it was really strict, particularly in renovations. It was requiring you to do things thermally that you can't quite do in an existing building. So they changed that. And so I would say it was definitely overly strict for existing for existing buildings. And it kind of adjusted. And so now it feels fair. For new construction, when we first read it, we're like, how are we meeting this? And the reality is that you can't beat it. You just need to think. We just saw some awesome sessions on how you think about wrapping insulation around certain details. How do we prevent heat from being lost?
So do you feel there's a
So-
little more leeway in existing? Obviously, in
It's,
existing.
it's not more leeway, and I would think it's equally fair, but the goal view value is different. Not only that, but how you account for things. There's certain things that structurally you cannot change in an existing building that you can definitely design to in a new building, right? And so wrapping insulation around, or thinking about, you put a thermal break in your balcony. Let's put it that way, right? If you have a balcony, and so there's lots of thermal breaks that one can add to a balcony when you're designing for new construction. If you're inheriting an existing building that has a balcony, unless you come in and you saw off the balcony and redo it, you can't do that. And so there are certain projects we will be presenting on one of the projects that we worked on, but there's certain projects where you just couldn't before this got more lenient, or more relaxed or more
And
reasonable.
if they upgrade their envelope, or
Yeah.
I don't know the specific code, but if you upgrade lighting, glazing,
Yeah.
anything, roofing even,
Yeah.
does that trigger everything all of a sudden needs to?
But that's where it gets really complicated. And that's where we get into section. There are different types of renovation, of alterations. So you could have, there's different paths. So you could have an alteration. If you fall into alteration, you only need to upgrade what you touch. If you fall into change of use, which is the scary one, everyone should know whether their project is change of use or not. And many people go into thinking, oh, we're just renovating the fourth floor. Well, that could be change of use. If it falls into the category change of use, which is not the change of use as defined by the building code, right? It's not like you're going from a school to, say, an office building, and so you're changing the use per the building code. This is different. DOER defined it differently. But if you are change of use, then you need to upgrade for a space, everything in that space. The mechanical, like you need to bring up to code everything within that space. Whereas if you fall in the alteration, you only upgrade the element in that space that's being touched. And whether you fall into that or not can get very tricky for certain projects.
I love this topic, and we could talk for an hour on it, and
Yeah.
that's not the
No.
availability we have today. But on a final note, I think you kind of have a little bit of a gem here,
Yeah.
and I don't mean to toot
Okay.
your horn, but
Yeah.
seriously, because I think and I don't know, it'd be
Yeah.
interesting to hear just your business
Yeah.
model, who you're targeting, because contractors need help with this,
Yeah.
manufacturers need help with this, architects,
Yeah.
facade consultants. I talk to every one of them across the whole span,
Yeah.
and every one of them says, we got to lean into our, code specialists internally,
Yeah.
if they even have that.
Yeah.
Yes. So we offer code support to everyone. We work mainly with architects, but those are and owners, and those architects have started to bring in the conversation to the construction side because we are being so rigorous with how we are designing and helping them design their building that then we need to make sure it gets built the same way. And so we need to have meetings where we say, well, this is how you need to do it. Then they'll say, well, can you help us? And then we're like, yes, we can. Right. Yes, we can help. There's sometimes, so to clarify, Airlit, which is the company I represent, is not an envelope consultant. Like we don't do envelope consulting per se.
You consult.
We do energy. We consult because we do energy code consulting, and so we help on envelope and we help on everything else. We can't tell you, with envelope consultant certainty, right? That this, that if you add so much insulation in your brick, what is the implication to your vapor barrier into this, into this, into that? For that, we typically team up. So we have partners in the industry that we typically pick up the phone and call. So the moment we're getting into how do you actually make sure that the detail, that all the barriers are properly accounted for, and that we're not just talking about insulation here, but we're talking about all of the other elements and how are you fastening it and in what order are you building this stuff? Then we call our construction sequencing, right? So what I could be recommending thermally someone might tell you, well, how do I put it? Yeah, how do I put it there? Well, no, that's a really good question. Envelope consultants have an answer for that. And so we have a couple of envelope consultants that we partner with, we're presenting with today, that will do that part. And so we'll call up and say, okay, this is where my expertise ends. Can you tell me in terms of sequencing, how do you typically do it? And is what we're recommending consistent with that? And then they can come in and recommend certain projects. So we team up with whoever needs it. We're here to help. It took us quite a bit. We weren't, to be clear, we do offer a bunch of other services that aren't code related. We actually never thought we were going to be doing code, except that we started working on code a year before the stretch code was released, because we happened to have a project that we knew was going to have to meet it. And we spent a year getting effectively a 1-year PhD on stretch code, to the point that when the stretch code was published, we already had a year in, and all the questions that everyone was asking, we're like, oh yeah, we know the answer to that, and we know the answer to that. And so, we're providing clarity. We like to say we provide clarity to teams in terms of what they need to do. Sometimes they don't need to stress too much about code. That's an awesome thing. Sometimes we say, you should be evaluating this in study phase. We see a lot of owners who, again, think they're just renovating the 4th floor. If that 4th floor falls under change of use, that means they need to upgrade the entire envelope, which means of the 4th floor, mind you, but that means they need to replace the windows of the 4th floor. And so then they would end up with a building that has 1st, 2nd, 3rd, 5th, and 6th floors with a certain type of window, and the 4th floor with different. So it kind of starts to mean a full building window replacement, which is not something they envision when they said, oh, we should turn, that office space we have, we should turn it into classrooms. Could be changes. So we could try to provide clarity.
Thank you for coming on. I would expect her to come on a future episode.
Yeah.
And thanks everybody.
Thank you.
All right, so we're back with the next edition, and we have Shu joining us after the panel conversation. And actually super interesting topic that I do want to dive into. So maybe you could present it, but primarily focused on spandrel areas as it relates to energy performance.
Well, in particular, spandrel areas within glazed aluminum systems has been an area of study at RDH for a very long time. In Vancouver, we have a thermal analytics department that has really spearheaded. And what I showed today, they've shown 10 years ago. But I think now with the new code change, people are ready to listen to it.
We were talking with Alejandro before about stretch code coming, and then it kind of taking everybody aback, and it's so up to interpretation by a lot of people. So the challenge of not only meeting the code requirements, but how to interpret the code is a lot of what you were focused on in unitized assemblies, or does it become more challenging if you get into stick built components or rain screen assemblies constructed on site?
The theory of it applies to all glazed aluminum systems, but I think where we see its application the most is in unitized systems when we go tall, because for low to mid-rise, there are a lot of different options for how to build a building and how to build a building very thermally efficiently. So I think that where you have a great volume, enough volume of panels where it actually makes a big difference, that's in the tall buildings that we see, which is unitized curtain wall.
How does this play into what code requirements are when it comes to reporting thermal bridging? And when you do a model like this, you report to the team that their overall as-built system performance might be 10%, 20% lower. than expected when factoring in the spandrel conditions. So does that mean you kind of like, so you put in like a factor of safety, or you have to upsize all the performance versus what they're actually getting real blood?
Yes, and I mean the Massachusetts Code, the guidance documents, it's black and white. It says that spandrel panels in a glazed wall system have to be 3D modeled, and they also list a reference method of derating because they understand that 3D modeling is a very specialized area of expertise. Very few companies can do it. So the building envelope thermal bridging guide, or BET-BAG as we call it, is a free online tool that you can filter different types of pre-modeled 3D models and you could use that as a starting point for your design.
Is it, I want to say who's responsible? Ultimately, the architect of record has to be specifying and delivering construction documents that are code compliant, but do you lean on the current wall contractors to do a lot of that in-house thermal modeling? Are you contracted through contractors or through the design team to help assist with that modeling?
It's been a bit of a journey, an interesting one. And in the last year, we've had, so on the architect side, the architect, if they're stamping, then they take responsibility for the interpretation of what they're finding on BET-BAG. And when they hire a consultant like us, then we are able to look very quickly and advise them. So that gives them that extra kind of assurance. Sometimes they don't want anything to do with the stamping of the backstop calculations, and then we do that for them. And in order to prove out that a manufacturer's system can be equivalent or better than what the architect has designed, we've been partnering with installers and manufacturers to help them bridge that gap, and sometimes provide the consulting to see whether they can use some of the free resources or do the modeling for them. There was a recent project that we did last year where there was an interesting setup, and we worked for the architect and the fabricator, and our code compliance document ended up being the submittal as well.
Wow.
Yeah. So it was a very efficient process, and we were able to, through that collaboration, fill in the gaps. Because when you do the backstop, you're not only putting inputs of the glaze systems, the proprietary systems that your fabricators are providing, you're also measuring the linear thermal bridges that are between the window and the wall. Sometimes, certain manufacturers don't do that. They don't want to touch it, or the design is still evolving, and we don't know what that is and have to make an assumption and some kind of model. So working with both the architect and the fabricator for this, unique combined document was actually, it helped the process.
I think one area that's very problematic when it comes to thermal performance and asphalt conditions is air filtration or air loss or leakage, rather interface conditions or operable windows. And I think that's something that you can measure, whether it's blower door testing or timber testing. You can model the spandrel condition and interface conditions and try to isolate. This is a thermal bridge. We need to separate or create some type of separation between the metal components, or add insulation, or add a thermal break here. But is there any sort of a measuring tool or means of accounting for the actual as-built performance and going back and doing some type of like thermal imaging or something to identify this is what we modeled and then we built it and then this is the as-built condition?
Yeah.
Described.
I see what you're saying. Once the system is installed in the building, sure, that there's the infrared imaging that shows you where the holes are, but it doesn't measure the U value of the linear thermal bridge for your check, right? I think, but I think what has been established through physical testing and some of the work of the Charles Pankow through the Charles Pankow Foundation is that, and I think part of the reason for that study was so that we can sort of define, how we model to make sure that it matches the tested conditions.
And are you finding this is becoming more and more so standard practice on RDH projects? Or is that the goal?
Yes, I think it has been, and it was a big education for me. After joining, I've been at RDH for 4 years, and I know when I first came on board 4 years ago, and we were still in the old code. I worked for a manufacturer, so I was very much in the mindset of like, why do we need to do this? And I think RDH has been in that mindset for a long time, and it's just part of how we think about operational energy and the envelope.
Amazing. All right. Well, Shu, thank you for sharing your insights with us, and I appreciate the conversation.
Thank you.
All right, our last segment, we got Bam, and really good you're in the panel. And I think it'd be really good to touch into a real theme, obviously just with stretch code and the complexities we see in this market around high-end new construction, whether it's mid or high-rise unitized versus restoring a lot of the institutional buildings and addressing thermal performance in existing buildings, is how to address stuff like thermal bridging, heat loss, reporting thermal bridging, and so forth. Stuff like the accounting measures, whether it's BERDO, measuring as-built performance, more simple, it's just designed. But when it comes to helping either fabricators, contractors, or design teams in the design process, maybe you could share a little bit about what you do from a professional standpoint, but what you focus on, and it's sort of deconstructing that, demystifying a lot of it, and helping them make more informed decisions.
Yeah. So usually in our practice, we end up working directly with the architect. What we like to say is that we want to be an extension of the technical department for any firm that we work with. And a lot of what we end up doing under the stretch code that we have here, there's that requirement to deal with thermal bridges within buildings, whether that's in existing buildings or new construction. And that can just seem like a lot to take on, right? If you haven't had to do that math before, you haven't had to run therm. What we've found very quickly with the code is that the prescriptive values carry for thermal bridging to allow you to just look at the code reference for it, pick a value, and then do the math on your own, are incredibly conservative. And they're intentionally conservative so that it pushes teams to look to do other methods, whether that's using therm or looking at the British Columbia Hydro Guide, which is a compliance pathway with existing thermal bridging calcs. But a lot of what we end up doing is we've developed a catalog of these very typical conditions, and we run therm. We can understand generally where side values are going to fall. So early on in the project, we have been leveraging Rhino and Grasshopper to build models of the project as it develops, track where we anticipate there being linear bridging, and then using preliminary values that we've established for projects with a buffer on them. So that early on in the project, we can immediately start seeing what the impact's going to be. And as the project develops, we better understand what the detailing will be. We can start to run them specific to the project, import that, cross-reference it, and just kind of keep tightening our assumptions, always starting from a conservative place and working our way in.
So essentially what you're saying is taking the prescriptive route. These benchmarks or performance metrics that we're trying to achieve are overly conservative, with the intent that also you might have a little bit of we're talking about this in the last one with Shu, a little bit of a safety factor in that your U-value targets for a spandrel area might be X, but the as-built condition, when you look at it from a 3D model, might be 20% worse.
Right.
So with that in mind, with the backstop in mind, and the opportunity to take the performance path, should owners or developers be thinking about spending more upfront to take the performance path? Ultimately, because it's going to save dollars with the back end. People say stuff like, "Oh, to do less than 40% window to wall ratio, and your building will perform fine." That's a little bit of a typically done, so it's limited, but yeah.
So I guess trying to say that you're going to see savings on the back end, maybe not quite accurate. So the code had helped mandate a lot of best practices that the industry, especially here in Massachusetts, was already doing that improves thermal performance. But if you look at the proportion of your energy use intensity, the EUI that we track as a metric for buildings, it's very small. It has huge ramifications for the grid and for what we're doing for the climate, but the actual performance of the project, not a huge impact. To many projects, historically, we were treated as like, an envelope upgrade is like a rounding error, not there. So what the code has helped is like it now mandates a minimum requirement. That's why we call it a backstop, or it provides a mandate for what we have to achieve performance. That payback period sometimes can be beneficial. Usually it kind of just blends into everything else. It's not like it's going to be selling point of the, if we make these changes, we're going to see savings within the X period. That can be true. Usually it's by reduction of mechanical sizes, not by anything specific to the envelope.
So are you seeing envelope upgrades in existing buildings? Secondary, tertiary benefit might be lower operational costs, but for the most part, it really has to be driven by a greater driving force, whether it's enhanced occupancy or greater tenant rates, or either maybe an office to residential conversion, something, an underutilized asset trying to basically uplifted.
Yeah, existing buildings are a bit different in that usually, so depending on their age, they perform really, really poorly. So even before, in under previous versions of the code, newer buildings will perform quite well comparatively. Upgrading an existing building does have a huge benefit. And this is actually a place where the code here in Massachusetts updated here in 2025, because previously, if you were renovating a historic building, you had to treat it like you were doing a new building. All of the thermal bridging calculations, anywhere that you had existing thermal bridging, that can be really, really challenging in a building that already exists and you can't make many changes to. That has since been altered, where now, under the current version of the code, existing thermal bridges integral in nature to the building can be ignored. But it still allows you to take all the other benefits of improving thermal performance, make sure that new things we do in the building achieve those same targets. And that does have improvements to the occupants and comfort and to the long-term use. For clients that have occupied a building and intend to continue, that has a huge benefit.
So when people, interesting, you just said that existing buildings are performers. I think to classify like a 1980s, 90s curtain wall, which is obviously existing, but like a 2015 curtain wall is an existing building, but versus like a 1930s building that is super low window wall ratio, very deep brick cavities. Are those buildings for performance as well?
1930s gravity buildings, they still are. Yeah. I mean, not as bad as, so you kind of see like a performance driver, right? When fuel costs were still quite expensive in like 1800s on. We had deep wall cavities. We didn't have the technology glass that we had. So glass was already smaller. There was some benefit to that on thermal performance, but you're looking at a masonry that might perform at par 8 versus windows that at the time were performing at 1, par 1. As we went into like the 70s, 80s, 90s, then it became all glass, which was performing at like R2. So yeah, there was a dip. But R8 to R2 compared to buildings here in Massachusetts, which have to perform closer to the like R20 range, for aggregate value, it's just not even comparable. The amount of energy going into those buildings versus what we're doing now is drastically different. And whether you're comparing that all glass, but it's the masonry, there is some benefit in the masonry being masonry that there's thermal lag that existed. But it was still a major energy driver.
So where is your focus primarily now across all building type sectors, facade typologies?
Yeah, we don't really have a focus in our practice. We just we also do aspirational design. And that doesn't mean doing like the big flashy projects. We've worked on projects like in the reservations in Colorado, doing net zero low income housing, all the way to towers here in Boston, doing unitized thermal systems. We really just kind of chase projects that have teams who have like an aspiration to do better work, whatever that might mean.
Nice answer. Felipe, thanks for joining us, and super informative.
Thank you.
Nice day, Brad.
It was, yeah. We were really thrilled to be here in Boston. It's always fun working with local firms to bring these things together, and AECOM was a wonderful partner on this one. A lot of really great highlights from the presentation by Pelly Kendall Heaton, and to Handel and Socotec, to the really amazing conversation on Massachusetts stretch code. It was really just a fantastic.
I was going to say, for a guy who's not an envelope itself, that you got pretty into like how the when they would talk about thermal performance, and you get thermal bridging, kind of deal with stretch code, thermal bridging expansional areas. That one seems to pop out at you.
Yeah, for us, sustainability is in the DNA of the Facades conference. It's always been a big part. We call this the premier conference for high performance building enclosure. So it really it means something to be able to be at the bring the experts at the forefront of those conversations to the table and really help to educate architects. So that's always a highlight for me personally. Like the sustainability issues are just so important, and on a personal level, it's very important to me. So those always make me very happy to include in these programs.
And I thought it was super diverse in terms of showing architects possibilities, in terms of project implementation, hearing it from contractor owner's end all the way down to the envelope consultant, advise them on how to best implement these strategies, design and specify projects. So very diverse group, which it gives more of a complete picture about what's happening in the market.
Yeah, and I think that's the other part about what's what Facades Plus has become over the last 13 years is really a chance to bring together all players at the same table to educate each other, to connect, to make forge new connections, new possibilities. Many amazing projects and teams have come together because of this event. People launch their careers or successful runs within their firms because of the kind of connections they make at Facades Plus. So
it's really a thrill for us to be able to kind of bring everyone together across North America to have these conversations. And every city has its own little flavor to it as far as the kinds of projects, the kinds of teams. But we want to be able to make something for anyone with almost any skill level. We have the most senior architects who have started their own firms, and that kind of partner level, or and from independent contractors and facade consultants down to folks that are still in school, and really trying to provide something that will really impact their kind of careers and ways of thinking about design.
So what is something that you're looking forward to, something that Facades Plus show is looking to bring forward in the future? I mean, you have a massive lineup across the country coming up 2026. What are some things that are going to drive moving forward?
Yeah. I think the goal is to really, continue to find what's important within the industry, identify those trends, kind of what's coming, what's next, how people can continue to evolve good design and high performance design. So that's always been the goal and continues to be the goal, is to really forward that conversation. I think bringing new formats is important. We're always trying to make these conversations dynamic and find spaces to bring in more voices. So looking to bring in different aspects of the building enclosure field and of the AC field more generally. So finding conversations with maybe elements that we haven't previously been able to include. There's so many different specialty variety of consultants who are doing very important work, and there's people doing really important R&D. Hearing more industry voices, I'm hearing more contractor voices, and just continue to highlight what's really the best of design and construction.
That's the challenge for you, is to not lean on the partners. You always been leaning on in the past, to constantly dig deeper, find what's new in the market, what newer trends are happening. So we want to try to delve into this area that hasn't been explored.
Absolutely. No. And I think for us, it's about bridging existing relationships and then building out a much larger community. Sure, business is competitive for between partners, but design gets better when you work together. I think that's something that is in the DNA of what we do, is really to try to bring firms, bring people together to see what's next and what's going to be successful going forward.
Design was better when we work together. All right. Well, on that note, thank you, Marty. This was a lot of fun. A lot learned, and looking forward to the next one.
Me too. Thank you.